classes. And I do this for really two reasons. Most importantly, this is COVID. This is the pandemic. Things happen technologically. You might get kicked out for no fault of your own. I was in a meeting yesterday and power was lost in Poughkeepsie, New York, and I got kicked out of the meeting. I'm hoping power does not get lost in Poughkeepsie, New York today, because if it does, that means we'll all get kicked out of class for a little while. The recordings are there as sort of a backup if you are hit with something like that. And then secondarily, sometimes people like to go back through information if it goes a little bit of faster rate. I will say there is a drawback to these recordings. And one, that is people can rely on them too much. Our exams will be, well, they'll be take home, but they will be closed book. And that includes the video. If you're not sort of fully engaged in the class, assuming you're going to take time later to go back through the material, that can be problematic because not all of us go back through the material. I certainly didn't as a student. I would sort of hear it, process it, take notes, look through my notes, and then go forward with the information. So just keep that as sort of a pro and con in terms of the videos. Any questions with that? Okay, last question from me. Can you hear music in the background?
Yes.
Okay, it's too loud. Can you hear music now in the background?
No.
Great. When I'm in my office, I have the acoustics perfectly set up so that I can have a class going on with no knowledge that I also have pretty loud music directly in the background to keep me happy. Here, this environment, that clearly doesn't work as well. And in case you're curious, I'm listening to Olafur Arnalds, great Icelandic composer, very cool music. If you like sort of modern classical that combines electronic elements with string quartets and full orchestras, you may want to check them out. Okay, so on to class. This is animal behavior. And we'll talk a little bit today, hopefully the first part, kind of syllabi, boring stuff like that. And then the second part, hopefully get into some of the introduction to animal behavior. Beforehand, if you guys would, please take the pre-class survey quiz. This needs to be done now. I will close it at 5 p.m. today, and it's an automatic free quiz grade for doing it, not based on your overall performance, but it gives us a baseline for the type of knowledge and type of self-perception that we have. In addition, if you haven't done so already, please take the course verification quiz. It's a very complicated quiz, and that needs to be done to ensure you get your financial aid in a timely fashion if you are an individual that receives financial aid in any way, shape, and form. This quiz takes most people about, 5-10 minutes. It can take up to 15-20 minutes. So on that note, why don't we come back as a class at 11, let's say 11:05. Okay. While you take the quiz, if you want to mute your video, please don't hesitate. If you want to even drop out of the class, please don't hesitate. Just come back into the class by 11:05. Any questions before we get going? Okay, go ahead. Back to resume recording. And you guys can see the PowerPoint at this point? Thumbs up, yes, no? And is there a gray box that is sort of blocking your image? Good, I'm gonna assume that's a no. Excellent. So the first part of the class is well, okay, this part's very exciting. It's me. But then after that, it's, the bureaucracy of the class. Again, as I said earlier, don't hesitate. You can call me Dr. Gunnels or Billy. That is your choice. I tend to follow shiny object syndrome, and my interest in research tends to move quite a bit from probably in a 3 to 5 year cycle. But I do, my core interest from a very young age has been animal behavior, and particularly the evolution of behavioral patterns. I got my interest in science based on kind of confusion with the concept of altruism. And this really sort of spurred on from when I was around 12. I grew up Catholic. I would go to mass. If you are Catholic and you go to mass, I tend to find it a little boring because they didn't do anything. It was always the exact same rituals. So my father gave me a book so I wouldn't fall asleep, and it was about the Book of Saints. And as I was reading through this, they're all dying, like just one after the other. They're dying, until we get to around the 1200s and 1300s, and then they start surviving. But the early ones, they're dying left and right. And I was very confused about why an individual would provide a benefit to others that is a direct cost to themselves. I didn't go into theology to address it. Instead, I got into science. And much of my early work was associated with this paper wasp right here, Miscosyrus mexicanus, which shows an interesting form of altruism, wherein some times they can choose to be reproductively altruistic, sharing resources, and other times they're reproductively selfish. Recently, I've become increasingly interested in urban ecology and behavior conservation, and I'll show that in a second. And scientifically, I'm also very interested in human-animal interactions. In a few years, almost maybe about 10 years ago now, I did a lot of work in terms of human and canine signaling and how canines use information from us to understand their overall environment. In addition to the sciences, I like to do multidisciplinary research. So I work with a historian, and we've developed a field called historical zoology, where we use historical records to understand the behavior of animals that were alive 500, 700, 200 years ago. Animals which you couldn't do experiments on because they no longer exist, but there's records in people's journals that could give us some insights of what they're doing. So it's a lot like fossil research, frankly. I'm also interested in environmental sociology, why we understand the human and non-human systems. And we'll actually be doing a little bit of that on Thursday. And then last, I do a lot of what is called SOTL, Scholarship of Teaching and Learning, and I'll show you a little bit of that in a second. Some of the projects I'm working on right now, I appreciate the burrowing owl that we talked about, is associated with urban ecology. And these are two papers that I hope to have submitted, hopefully this one next week, and this one maybe in about a month or two. But this one is looking at how bald eagles use cell phone towers for nesting. And what you're looking at over here on the left is you're looking at the distribution of bald eagle nests between 2013 and 2017 across peninsular Florida. And because it's a relatively even color, that's saying that they're really distributed pretty evenly across the sample counties. The figure over here on the right is showing when bald eagles nest on cell phone towers. And while you see them nesting across the entire state, what do you guys notice about their use of cell phone towers?
There's a lot in Tampa.
There's a lot in Tampa. Basically, even though cell phone towers are evenly distributed across the sampling area, they're really only using towers along this I-4 corridor. There's a little bit down here in Southwest Florida, but it's primarily St. Petersburg through Orlando. We have some explanations and some thoughts as to why, but still very cool. And then what you're looking at here is you're looking at a study that comes from data in 2017 that is looking at how burrowing owls distribute across Cape Coral. And what we're seeing is inactive burrow clusters. These are the burrows that they dig out, but then don't end up using, versus active burrow clusters. These are the burrows that they dig out and then actively use. And there was some very surprising stuff in this study. One of the things that surprised us the most is that burrowing owls in Cape Coral tend to associate with the most dense residential neighborhoods. They nest almost exclusively in undeveloped lots, but they tend to set up their nest on undeveloped lots within a neighborhood that has a lot of human houses, which just kind of describes this relationship between human and non-human animal. Any question with those? So this is actually work that doing with Alex Marsh. He talked a little bit about this before. We're down in Peru, in the lower Amazon, Peruvian Amazon, and we've been looking at how reptiles and amphibians distribute across different environments. This is showing an overall species list and the expected biodiversity of reptiles and amphibians in this sampling area called Santa Cruz Forest Preserve. And then it's showing how different communities of reptiles and amphibians separate based on habitat features, whether it be a primary forest, a secondary forest, or a pasture. And what we noticed is that primary forests and secondary forests share a lot of overlapping species and tend to be quite different than pastures, but that there is some difference between the primary and secondary forests when you look at more subtle measures of variation. This is a project that is ongoing, and hopefully we'll have some more stuff about that soon. And actually, Alex is writing this up right now, and hopefully that will be submitted when, do you think?
I'm hoping end of February.
Ooh, I like that. I like that. I think that's optimistic. I'm going for March, but I like Alex's, yeah, let's vote for Alex. And then, as I said, I do a lot of scholarship of teaching and learning. I'll start over here on the left because I just got the proofs to this paper this morning. And what this is looking at is the role that the campus plays in terms of reinforcing the culture of sustainability that we have at FGCU. Whether you fully appreciate this or not, FGCU's campus is incredibly unique. Half our campus is conservation area, half of our campus is really an urbanized academic and residential core. And this is creating an environment where sort of we have both a very strong human presence and non-human presence very integrated together. It's a brilliant, brilliant model. What we looked at this paper is how the campus attracts some individuals who then use the campus for their teaching, their research, and their service in order to reinforce the actual sustainability of those human and non-human elements of the campus. So it's basically a circle of reinforcing associations. And I'm a good anecdote to that. I came to FGCU for a variety of reasons. One was our campus. The fact that I could be in Whitaker Hall in my office, and then within 2 minutes, be in Whitaker Pond and be able to work in a non-human natural system. And then if I needed to, get back into my office for office hours, with 2 minutes effort. That provided me sort of a great opportunity in terms of thinking about my profession. As a result, it affected my teaching, clearly affects my research, and affects my service, all of which goes back into reinforcing this connection between conservation and urban areas. This part right here, this is about you all. For the past 5 years, we've been doing this educational reform in order to help you develop skills that are most important for careers and lives after graduation, namely communication, critical thinking, information literacy. When we ask employers what they want of graduates, those are the top 3 things. They tend to say, we'll teach you the content you need. Like if you're going to medical school, you know that. You're getting a little background in terms of life sciences, getting a major in biology, but you're going to medical school to get that precise content training. What they want from you is that you can actually problem solve, that you can think through the information. You know how to filter out high quality and low quality evidence and information. So 5 years ago, we started a plan to basically try to improve these skills in you. What you're looking at is you're looking at an overall score that reflects 7 different measurements of your learning starting in 2015 through this past spring. And each one of these dots represents a single student for their overall score. And what you should notice is that there's just been this nice, steady improvement during the 5 years of this program as you guys have become better communicators, better thinkers, and better uses of information. I like that. That is good. The second one I put in here is because I am a total homer. In addition to being associate professor in biology, I'm also the director of our Office of Undergraduate Research and FGCU Scholars, and therefore support student and faculty mentored research. You may not know me personally, but if your faculty are working with undergraduate research students, they know me well, because a lot of what they need, we try to work and get and sort of make sure is accessible so that they can support you with the research that you do with them. What this figure is showing is it's showing what is called a CUR in CORAL. A CUR is a course undergraduate research experience. So it's a course that integrates research into that course. The blue is a traditional course, and this is an education course where This is what is called a gateway course. The student is getting into the major. The bars show the overall learning gains in terms of critical thinking, information literacy, and communication, and the height of the bar shows higher learning gains versus lower bars, which show lower learning gains. So these are the exact same courses. One is integrating research into it, and the other one is not. What do you guys notice?
That experience teaches you more than just reading.
Yeah. The research experience has a very strong effect on not only learning how to maybe use a pipette or learning how to run a gel or learning how to do a behavioral study, but it also translates into better performance in terms of communication and critical thinking. Skills, again, that you apply and you use elsewhere. Make sense? Cool. So that's me. Why don't we take a break here for the two students? I remember Julian, I know there's one other who have to make the transition on campus. Why don't you go and start doing that now? We'll take a 5-minute break. This class is 2 hours and 45 minutes. One, I cannot talk for 2 hours and 45 minutes. We'll have a lot of different times when we're sort of breaking out into breakout rooms and different sort of discussion groups. But in addition, trying to stay focused for 2 hours and 45 minutes is beyond sort of our normal abilities. What I need you guys to do is, if I am not giving you a break early enough, say something. Just ask, raise your hand. Gunnels, can we take a 5-minute break? And let's do it. We'll probably plan on at least one, more often than not, 2 breaks for each Zoom class. But I'm going to need your help to sort of remind me, because if I get into the flow and I'm grooving, I don't need a break. But you might be on the opposite side, being like, and getting more tired or more needing of the restroom or more needing of a cup of coffee. Make sense? Okay, so put yourself on mute, put your video on mute, come on back at 11:51. If you are transitioning onto campus, go and start doing that now. Resume recording. Okay, let me open up chat in case that pops in, and open up presenters. All right, office hours. As you guys noticed, my ability to get the Canvas page up and to sort of get the syllabus up was very late. So I have not had a chance to look at my calendar to figure out when office hours will be. But hopefully I'll have that maybe by next week. Obviously, you can always set up office hours by appointment. So don't hesitate. If you do not hear back from me quickly in terms of a request for appointment, please don't hesitate to email one of my 2 assistants, Santiago, who will be able to help you either schedule a time or get what you need from me. My schedule, well, I mean, all professor schedules are busy. Your schedule is busy. My schedule tends to be pretty stupid. And there'll be times during the course of a week where I am triple booked at any one point in time. And that's not a figure of speech. That is a literal statement. And there tends to be a lot of moving things around. You are the priority in terms of the things that I do as the student. But I do need sometimes your help to make sure that you're getting that support that you want. So that would include, if you don't hear from me, reach out to Santiago. He's excellent. He can get you in touch. Email is always a great source to get with me. However, if I do not reply within 24 hours, likelihood is I'm not going to catch that email. So if you don't get a response from me within 24 hours, just resend it. Don't add anything to it. Don't apologize. I'm sorry. Don't mean to pester you. Don't say you may have missed this. Just literally take the previous email and just send it again. I tend to look at emails early in the morning, and I wake up sometime between 5 and 5:30 most mornings. So I get on the computer sometime around 6 a.m. If you are an early riser, cheers. It will be good. We'll watch the sunrise together. If you're not, you're a late person, then a really good strategy is to send the email just before you fall asleep because it'll be the first thing on my queue. So both of those are two pretty good strategies. You can call my office phone. That's kind of nice because that sends a voicemail directly to my email. I'll see it, but don't hesitate to text. That's my number. You know, again, if you do, please put your name in the text message and put the context, and maybe plan on doing that every 3 or 4 texts. The first time you won't have your name. The second time I can easily see it. The third or fourth time there's now a chain, and or I may have deleted the previous text and I won't know. I do mentally shut down around 7 p.m. So I may not see it after 7 if it's urgent. Just maybe send multiple texts and my phone will just start to bang off. Most of the time, people send a text that just says something along the lines of, Gunnels, check your email. And that's pretty clear. Sometimes a text might be because you need something pretty urgently. And if it is particularly urgent, then just call. You know, call is immediate. Text is pretty quick reply. Email, more substantive reply. Make sense? Cool. My office has 2 social media feeds. Actually has more than that. You may want them since we do a lot of support for undergraduate research and different learning opportunities. There are a lot of initiatives that benefit you as students. Some of those your faculty pursue, some of you pursue. If you want to know about different events and opportunities around campus, please don't hesitate to join. Questions with that? Okay, so my thought about animal behavior is that we're going to try to help you build a combination of both content and skill. This is an introduction. This is an enormous field of science that influences every other aspect of science, whether that be engineering, where engineers use models of systems they see in the natural world to try different designs. I was just looking at a New York Times article about some aeronautic engineers that were using flying snakes to model out different types of wing patterns. To medicine, to vet, to general life. So it applies very, very broadly. It also utilizes some of the most important skills that we need as scientists, but then that we need as people. Skepticism, objectivity, rigor, thoroughness, multiple ways in which to look and examine and understand different issues. So instead of trying to treat this as a didactic course, where you're just getting sort of factoids, and then your responsibility is to regurgitate those factoids. What I want to do is give you an introduction to the field of animal behavior based on that content, but then based also on the skills that we use in behavior and use in science quite generally. As a result, we're not going to cover everything. In fact, we are going to bias our focus to mechanistic approaches to animal behavior. I think I heard someone earlier mention they'd taken behavioral ecology. Great course. I created that a number of years back. And when I did, I designed it so it focused on adaptive explanations of animal behavior, evolutionary patterns. So because that has a focus on sort of the evolution of behavioral patterns, we're going to focus our attention on more of the mechanistic approaches, the genetic, the neurological, the physiological, the endocrinology. We will look at phylogenetics, and we will look at adaptationist paradigms in order to sort of get a foundation for these mechanisms. But really starting at about 2/3 of the way through the semester, our focus will be almost exclusively in mechanisms of behavioral expression. If you are interested in getting sort of that full introduction to animal behavior, then I would encourage you at some point to take behavioral ecology. Make sense? And I did that for a very simple reason. I was teaching both of them, and I thought it was really boring to teach the same thing twice. So it just seemed like a pretty simple way to sort of separate out the foci so that people got a more rich experience. Text and syllabi. So this is the required text. It's getting a little long in the tooth, and I apologize. I like it for a few reasons. One, this explore animal behavior is it's a compendium of readings from a journal called American Scientist. And American Scientist is a form of secondary literature that summarizes research programs to sort of provide scientists a generalized understanding of different fields. So they publish on everything, quantum mechanics, analytical chemistry, biochemistry, genetics, environmental science, but also, behavioral biology. And they have quite a bit. And what these authors did, Sherman and Alcock, is they went through the 100+ years of the journal and they brought out examples that show the historical development of the field, and then also address different kind of cool research programs that have explored behavior. I like it because it doesn't read like a textbook. Instead, it reads like a research program, and you get an overview of endocrinological functions that lead to alloparental care within Florida scrub jays, which, if you haven't seen a Florida scrub jay, is a kick-ass animal. Alloparental care means the offspring take care of their siblings and their cousins, which is so wicked cool. And endocrinological sort of determinants of that. Well, one, that's a misnomer, it's not true. But then two, the idea that the hormone system and how it regulates and maintains behaviors is just flipping awesome. So instead of reading 30, 40 different papers that sort of pull this together, we have one general audience writing that kind of illustrate that. It is long in the tooth. The last time they updated this was in 2013. If we do simple math, that's 8 years ago. That's a long time in science. So it's required-ish. I actually think I'm going to scan the chapters that we'll be using and make them available on Canvas. If you are interested, it's cheap. That's the other thing I like. I like cheap. I don't like to pay a lot of anything. I like to be cheap, especially with my science. There's a lot of machines that are expensive that go bing. We need to pay the money for those. There's a lot of cool stuff that we could do on nickels and dimes or free. And when we can, let's use the money for the Bing machines and the money for salaries. Let's use free things to do other stuff. So if you buy it new, it's $40. If you buy it used, it's much cheaper. And there's a lot more than we will cover in a class. So if you're kind of interested, it's a great resource. A few years back, I did not require a textbook. And there was a mutiny from about 25% of the class. They wanted a textbook. I get it. They wanted a secondary source to kind of read through to get a better understanding of what we were discussing and describing in class. If you do want a supplemental text that kind of parallels many of the things that we talk about in class, I like this text quite a bit. I'd encourage you to do it. Honestly, you could really use any of the animal behavior texts, and there's quite a few. There's at least 5 or 6 leading textbooks in animal behavior, but I like this one because it approaches it from a scientific process, how we do, what we learn from the research we do, instead of just, like, you guys took Bio 1, right? You had the Campbell textbook? Yeah, how many hands do I get for that? Yeah, not just announcing one fact or another. There's no logic of like how this information can be, why the questions were being asked. It's just sort of one trivia point after another trivia point. It's good, it's comprehensive, but it's not very sciencey. This does a good job approaching the science. If you want that, it's a great resource. If you have another one that works for you, use that. But that was only if you want sort of some additional supplemental information to help sort of think through the ideas. Cool? Make sense? The Sherman and Alcock, that is available in the bookstore. It's also available on Amazon. It's also available on Abbey Books or anywhere you can find books. And again, I'll make this available on Canvas, but I will need your help to remind me. Cool? Okay. Additional resources. Some other books that are, well, like this is a required read. If you are interested in any aspect of modern culture, i.e. memes, and or the connection between genes and traits, specifically behavioral traits, regardless of whether you're interested in medicine, rehabilitation, vets, wildlife. This is a required read at some point. Richard Dawkins is a popular scientific writer. His early work was really generating ideas in the text. So it wasn't sort of a think piece or a summary of other people's work. It was really a text to sort of think through what might be going on biologically. And the most famous of these, and probably the most impactful of these, is something called the selfish gene, which by the way, was named after a pair of pants that were in a kiosk. Then on the butt of the pants, someone wrote a tag that said selfish, and that's where the selfish gene became the selfish gene, the first modern use of a meme, to which he then develops the concept of memes in the Bloody Book as a cultural unit of inheritance. So it's a great book, well worth reading. We will talk about at least a few of the ideas like the Greenbeard hypothesis, but excellent. If you're a geek on the history of science, this is a fantastic introduction to the history of science. And what it does is it brings together the seminal papers of animal behavior, really starting from the early 1800s. And it provides commentary up through around 1960, 96, when we were starting to look more at the mechanisms of behavior in terms of how to understand this. Not everyone's a geek in the history of science, but if you're one of these people, this is a great, great text because it's the real papers with commentary on the side about how to think about them and where they came from and stuff like that. And then last is this series. And it makes me sad that it died. These were a series of textbooks, but they were unlike any other textbook I'd ever seen. They were called Behavioral Ecology and Evolutionary Approach, Krebs and Davies, and then you got Dawkins, Giraldi, and Kelsey. And basically what they were was a text about the field of behavioral ecology at that point in time. So there were edited volumes. Each chapter was written by a researcher in that field. Each text was a radical change from one book to the other. So again, you guys remember Campbell? How many people used the edition of Campbell when you took Bio 1? Anyone? How many people just found a random old used one that was maybe 2 or 3 editions earlier? And how big of a departure were those two versions? Maybe like we added transposable element or selfish genetic elements in there. These fundamentally different. So the initial one was very descriptive. The middle one was really based on modeling and really heavily into modeling as behavioral ecologists start to steal from economists to better understand behavior. The next one was really focused on genetics as sort of the use of genes from the 70s and 80s really started to give us some foundational insights into what was going on with animals. And then the last one in this series was really focused on mechanisms. When it switched over, it kind of went back to a more modeling approach. And these are awesome. Again, if you're really geek in this field, in addition, you kind of geek into both the history as well as the sort of the extent of the field. These are awesome, awesome texts. Some of them are very hard to find. That one at this point is borderline impossible too. I do have a copy of it, so if you want to see it, more than welcome, come by the office. I like free. I mentioned this. I like free a lot. R, it's a statistical language it is a software language for statistical modeling. It is fantastic. It is free. It is amazing. It's wonderful. It has a little bit of a learning curve, which by a little bit, I mean, I think I'm now stretching to the extent of the screen. It has a learning curve. It really does. But it's a great, great resource. R Studio is a skin that sits on top of R, which makes it much more usable. Also free, very good resource. A few of you guys have taken biostats. If you haven't, you may want to. It's probably one of the most important things you can learn as a science student. And if you've taken biostats, I always said that I teach biostats basically according to me, just for you guys. And I'm looking at Connor and Cortland on my screen at this point in time. I think Dakota, you're a little bit lower. I just actually took a class in R this past Christmas. I never took a class. I never learned it properly. I just learned it by doing it. So it's a very bastardized form that I teach. I actually learned it properly over Christmas, and it was fun. If you are looking at quantifying behavioral data, and you have to, because if you don't quantify and you don't quantify carefully, what you get is gibberish. And bad science is bad science, and I have no patience for bad science. JWatcher is a free tool for automating and quantifying behavioral traits. It's a really nice tool. We're not going to use it in this class. I think behavioral ecology may use it. I use a paid version just because I had the money and it's easier. So data analysis in Excel is good. And at this point, no more Stats Plus. Stats Plus sucks. I hate it. If you're going to get into it, data analysis is an add-on that is for both Windows and Mac. Finally got it recently, but eventually you're going to want to convert over to R and maybe even Python. Questions with this? Anyone really excited about R now? Like, yeah, more stats. Yeah. Okay, good. I'm glad I got that positive affirmation. Learning outcomes you can expect. And again, I said this is a combination of skill and content. I hope by the end of the semester, you're able to think more critically about your science. My goal by the end of the semester is that you have an increased understanding of mathematics and statistical literacy. As we, I mean, 2020 and 2021 were crazy and honestly ridiculous failures. In no small measure because most people are mathematically and statistically illiterate. They do not know how to process information that is statistical or mathematical in nature. And as a result, they were unable to understand what the virus meant, what transmissions mean, what R values mean, what sort of rates mean. And we have a bunch of belief systems that confounded an issue, which made something that really was going to be dangerous far, far worse than it ever needed to be. So yes, I do think I have a responsibility to help you become a little bit more literate in terms of understanding mathematics and understanding statistics. In addition, how to communicate quantitative information and what you're saying when you communicate quantitative information. This is science. This is the core of all sciences. And in many ways, that is one of the central tenets of science, is a quantification of traits, whether they be genetic, physiological, behavioral in nature. You will be developing your written communication skills to basically communicate both to a scientific audience and beyond that scientific audience. There'll be a lot of yapping, and I yap too much. I know that. I apologize. But you will also have many opportunities to yap, to which I look forward to hearing your voice. Information literacy. If mathematical and statistical illiteracy was a problem during this pandemic, probably the second most, if not most important thing was information literacy. We have gone through a revolution in my lifetime, which is wonderful. I grew up in a completely illiterate culture. I grew up in a culture that had no access to information. And if you talk to your parents and your grandparents, they can tell you about these stories of sitting around a dinner table on a Friday evening where there would be a question about who won the Academy Awards, some little trivia, right? And there would be big fights over who won the Academy Award. And the reason there would be big fights is people would have different beliefs about who won the Academy Award. Let's say Best Picture. I don't know. What was it? Parasite last time? And someone else says, no, it was Once Upon a Time in Hollywood. And they would just fight with each other. And the trouble was, there was no way of answering the question because the newspapers were recycled. It was Friday night, so the library wasn't open. And there was no internet, let alone no cell phone. This has completely changed how the world understands itself. Because any question that we have instantaneous access to find out about. The trouble, or can anyone think of what the trouble might be? And on that, I want to start with Audrey. Audrey, what's the trouble?
Like the trouble with phones and like that and like the information you get is it's not always true, and um, it's not. Some people won't do like the research to find out what is accurate and what isn't, and yeah.
I think that's a great observation. We have instantaneous access to information. It doesn't mean that the information is valid or not. And I think one of the things, Aubrey, you said in there was very good. We honestly try to get the information. That's great. One of the things we know with people is people are not swayed by evidence. People are swayed by personalities that tell them about evidence. So if you believe and you trust an individual, you are far more likely to believe what they say versus what you receive in terms of evidence. This is a real problem if you're trying to get evidence from this machine and you can't differentiate what is actual information versus what is someone else's opinion. And we've watched this, for the past, I don't know, at least 10 months. So Aubrey, very good observation, very good understanding. Trust me, I would prefer to live with this. This is flipping awesome. The dark days and the dark ages of the 1980s, the 1970s, and the early 1990s sucked. Once the internet became readily available, and once it became immediately accessible, the ability to learn about anything at any time is instantaneously available. But we have a new responsibility. And that new responsibility is to be the better stewards of that information. I remember when the pandemic first hit, I was talking with this animal behavior class last year. And when the pandemic first hit, one of the things I talked about with the class is you, as students of biology, have a unique responsibility to understand the science of the pandemic and then to share that with your family and friends, because they're not going to be able to understand it. They're smart, they're more than capable, but they're going to hear things from all over the place, and we're generating the knowledge about the virus at the same time that we're trying to deal with the virus. But as science students, you have a degree of expertise that very few people on the planet have, and therefore you have a responsibility in terms of reading it, making sense of it, and then because people trust you, sharing it to those individuals that can make use of it. And then if we don't do that, then we're kind of shirking our responsibility. So, not surprisingly, I'm going to try to help you guys develop some information literacy skills. Make sense? In addition, professionalism. And then, of course, this is science. We're geeks for science. Science rocks. So we'll be working in scientific process as well. Some of the content we're going to deal with. Well, one of the most important concepts that will be critical to any career I heard in the introductions is the concept of Umwelt and theory of mind. Because the concept of Umwelt, why it was generated and developed in terms of understanding animals, applies to every interaction with a non-self individual. So anything that's beyond you, your person. So if you want to be a good medical doctor, having a good understanding of Umwelt is going to be critical to you doing a good job in your profession. If you want to be a good dentist, you want to do good animal rehabilitation, you want to do good wildlife biology or be a good vet. In all those cases, understanding this concept and then using this concept in terms of how you interact with whoever you are will greatly benefit your understanding of the individual or the animal or the situation, and therefore your ability to serve that issue. We're going to be talking a little bit about the epistemology of behavioral thought, where it came from, why we actually do what we do. The development of a science is not built in an abstraction. It's not run by a computer program that says you will start to do it. So instead, it's developed by personal interests, biases, constraints, opportunities. And we're going to understand how this field came into be. We're going to look at the difference between ultimate and proximate explanations, where ultimate explanations are really that behavioral ecology domain and proximate is going to be our domain. And then as a result, we're going to look at these different topics. We're going to look at behavioral genetics, behavioral phylogenetics, sensory systems, development, neuroethology, endocrinology, among others. And what you can notice in this sort of list is really what we're going to be doing is we're going to be taking topics you've probably taken courses in, a course in endocrinology, a course in development and biological development. And we're going to be applying those ideas to animal behavior. And then at the end of the semester, I like to do a choose your own adventure, so that every year it's a little bit different for me and it doesn't become sort of boring. So some of the topics that we may be talking about, depending on what you want to explore, are things like the concept of morality as applied to animal behavior. Not morality in sense of our ethics, but the ethics of non-human animals and what ethics might mean in terms of how non-human animals interact with each other. We could potentially explore domestication. We could potentially explore behavioral conservation. And there'll be some others that I'll add to a list of topics that we may want to address and discuss. But those are sort of the goals. And I will update the syllabus, hopefully in the next, I don't know, maybe by early next week, to identify and align where you might expect certain learning goals with the different topics we discuss. Grades is how it's going to split up. Exam, there'll be 2 of them, represents 30% of your grade. Scientific biography, there'll be 1 of them, represents 30% of your grade. We'll have lab write-ups, 10%. We'll have reading journals and reading quizzes, 10%. We'll have a peer evaluation, 5%. There will be a participation score, 5%. And there'll be attendance. And I'll talk about attendance in just a half a second. But that is going to be out of 10 points. Well, 10 points, not 5 points, 10 points. And then for each class that you miss, it's unexcused, you just lose a point. So 1% of the final grade. The scientific biography. I've decided, that's probably the best way. I could say discovered, but that's a little bit, maybe too arrogant. But I've decided that students have a difficult time developing questions of scientific interest. And I think this in large measure is about our culture at FGCU. We are a culture that is first and foremost interested in service, which is awesome. And therefore, most of the questions that we develop at FGCU are questions that address a problem. Maybe it's the role of sunscreen in development of cancers. Awesome research. Maybe it's the role of, I think I heard the management of sea turtle populations. Great question. These are really important topics that address problems that need to be fixed. These are worthwhile efforts. But part of science is also really pushing at the edge of our fundamental knowledge, our basic knowledge, sort of what is life, the universe, and everything. And for those questions don't tend to be addressing a problem. They actually may just be something of fundamental scientific interest because it's an issue that we don't have an answer to. Give you an example. That's borderline trivia. What happens here, tips of your fingers and your toes when you get them wet?
Like they turn pruny.
They turn pruny. Well, a buddy of mine asked the question, why? Why do they turn pruny? Guy by the name of Mark Changizi. Anyone know the answer to why they turn pruny? Because it's actually become part of our pop culture.
Doesn't it have to do with grip?
It does. The pruny acts like tire treads. So when you grab onto a smooth object, like a smooth cup of coffee, that pruny will push out and funnel the water away from your fingers so that you can have a more solid grip on an object. It was first developed as a question, silly question too, because the person who actually came up with the question refused to make this their PhD focus. It was their research mentor who recognized that's a pretty damn cool question and finished the work to actually do it. The guy who was doing this for his PhD didn't want to be known as the pruny finger researcher. So refused to do it. It came up with a much more boring research project. But it's just a basic project of science, a basic idea of science. There's a lot of very interesting topics that are this type of nature. And sometimes they do come up with applications afterwards. but their initial purpose is just to learn and just to discover. So what I want us to do is a scientific biography, and we'll talk about this throughout the semester, where you're going to follow one researcher of your choice. There'll be a few researchers on the blacklist that I just don't want to read about anymore. Sorry. I don't want to read about Diane Fossey anymore. I don't want to read about Jane Goodall anymore. I don't want to read about E.O. Wilson. Don't want to read about Dawkins. Don't want to read about Pavlov. There'll be a few that I'm going to take off the list. But all the researchers, you'll be able to track their career through the type of work that they did in order to understand how they developed the questions that they did, and then using their intellectual history, suggest where that field should be going. This is a project that could be done as a group or an individual, and it'll be broken up into many different pieces so that by the end of the semester, you have something that you like. And just so you know, well, one, I don't know anyone else who does this project. And two, there have been 2 students who have published this work as a form of academic literature because it is a real comprehensive understanding of an individual. You don't have to publish it. You don't have to feel that obligation. But if it really kicks off and you get something that is, really kind of novel, then you may want to. On participation, I'm going to grade you on your participation. Obviously, having your video on is part of your participation. Some thoughts and some things that I look for in terms of evaluating that grade is that, you ask questions. One, it makes the class much more interesting for me. Two, it'll make the class much more interesting from you. Who wants to hear my voice for 2 hours and 45 minutes? Go ahead, raise your hand. If that's your goal, please get them high. Because my guess is no. I like my voice. I like my mannerisms. But even that, I think, might be too much for people. So asking questions, answering questions are key. And I have a random list, and Aubrey, you did a great job with the first one. Making comments, some value-added things. I particularly like it when the discussion is not me. And we'll have chances to do that both together as well as in breakout rooms, where really you guys are having discussions with each other that doesn't have to go through me as the professor. And also, I'm very happy when there is disagreement, when it is respectful and thoughtful, and it's evidential, that there's some substance to it. And that can mean sometimes coming back at information. I'll put up a preliminary grade sometime after the first exam, and then of course that can change during the course of the semester based on you. And with all grading, if there's anything that you ever disagree with, don't hesitate to give me a yell. If you're right and it benefits you, I'll make the adjustment for you. If you're right and you hurt you, I won't make any changes. And if you're wrong, generally you'll get a better sense of what's going on and you'll feel more informed. So don't hesitate. Attendance. I take off 1 point out of 10 points for every class that you miss starting in the second week. And there's really 2 main reasons for this. One, part of our job is to help you become more professional. Classes are a good place to be professional. Part of a university's job is to help you learn how to accommodate failing, fixing, and improving. So we're going to do that. If you miss a class, no big deal, just 1 point, not a problem. The second reason that we're going to be doing this is because when people miss classes, that adversely affects other students. And you kind of think of why. If we're discussing a topic and I miss a class and I come into the next class and we're building off of that topic, the professor has to spend some time reinforcing it beyond what they would normally do so that anyone who misses isn't totally lost. I mean, not re-going through it, but has to spend some energy and some time to readdress it. Well, that hurts anyone that's already been there because it becomes redundant and it slows down the overall progress and it doesn't allow for sort of more rich and deep thoughts. So that's sort of where that policy comes from. I only started doing this about a year ago and I like it. There are excuses. And there's an additional excuse I put in the syllabus, but I didn't put it here. One, if the university requires you missing, no big deal. As an example, if you're in athletics, not a problem. Just tell me, keep on top of it, you're fine. If you're ill, injuries that require medical attention, no big deal. In addition, if you're doing something associated with research, and a lot of conferences this year are virtual, and therefore students have more access to participate, and you're in a virtual conference, just give me a yell. No big deal. Your excuse. And then I'm going to add another caveat. This is COVID-19. This is the pandemic. This is a society where we're grappling with racial injustice. We're grappling with political issues that are sort of emerging left to right. Things may come up. I don't know what they're going to be. If something does authentically come up, you have to address something in your family. You have to address something that, is just kind of aligned with the craziness. Just gives me a heads up. Not a problem. It will be excused. The attendance is really about those cases where, you weren't being responsible to your classwork and you weren't there. Does that make sense? However, I will score you as not there unless I do get that information. So after each class, I generally go into attendance, I list that in. If you do see your name come up as missing something and there's a valid reason for it, just give me a yell afterwards. Honors embedded experience. A number of students are in honors, the Honors College here. If you're part of that and you want to participate in the embedded experience, or you're not in honors, but these two things strike you as kind of geeky cool and you want to participate, as a group, we're going to decide on one of two approaches. One, and I did this past spring and I liked it, and that is a short 5 to 10 minute cell phone animal behavior video that uses the literature to describe a behavioral trait. And we did this last year and it was pretty awesome. One was on coloration of bearded lizards. One was on shrike foraging patterns and includes the observation that Alex Marsh talked about earlier, where they impale prey as either food storage and or courtship. One was on goat development and goat play behavior. So they were fun. Alternatively, for those students that decide to participate, you could create a wiki page or wiki entry where you basically translate the scientific literature to something that is encyclopedic and understandable to a general audience with appropriate references. You learn how to format, integrate, use wiki, and then you actually create and publish a wiki. So probably in a few weeks, I'll bring together those individuals that want to do it. And we'll talk about which of those two approaches that they want to do. Both I like, both are interesting, and both are kind of geeky. Materials. You're going to want to keep a notebook, especially in those times when we're in the field. You're going to keep a note, and I'll be grabbing those on occasion from you, probably once early in the semester, maybe once later in the semester. For field work, I would encourage Write in Rain. I would encourage the hardcover version of Write in Rain. These are the model numbers for those. I'd encourage either 4x7 or 5x8, so it has a little bit of substance. The little bitty notebooks, they're just kind of silly. They're cheap, but they're silly. A typical notebook that is the hardcover might run you up to about $20, but there's no textbook being assigned. They're good for two reasons. One, you can write in any weather. And if we're in the field and it's nasty weather, you can write, no big deal. Two, if they're hardcover, they don't go away. And on that note, you're going to want a notebook. Do not get a spiral notebook. And do not get a spiral Write in Rain notebook. And I would like a Taylor Day. Please tell me why you do not want to get a spiral notebook.
Well, you said that the all-weather field one is really good with bad weather, so I'm sure with spiral notebooks, they're not really well, and also the papers will fall out easy.
And data are sacred. You do not screw with data. And therefore, you never want to have the option of removing data from your notebook. So Taylor, that was a perfect description. No spiral notebooks. All three of those locations, Amazon, BioQuip, Trail Explorer, have access to it. Honestly, I would probably get it from Amazon because if you have Prime, it could be here in 2 days. If you don't have Prime, it could be here in a little bit of time. You need it by next Thursday, so this should give you a week and a half to get it. Typically, our bookstore has these in the bookstore, but that's not a guarantee, and some semesters they don't. Questions? Okay. I'm going to ask that you take notes in a particular format. In the top of your page, when you take notes handwritten, and I do not expect you to handwrite out class notes. You're on a computer. If you're not using a computer, that's crazy. But anytime we're in a field, the top should say field, class, discussion, whatever it is, to give some indicate as a tab about what the page is referencing. And the top of each page should have a title that describes what the overall page is going to be describing. If it is the same topic going from one page to another, you still put the title, you just put continued. And then for each observation, you want to have a timestamp that then includes whatever notes that you are taking. This is just an observation of an animal, such as this paper wasp, where you have a timestamp, a behavior, timestamp, behavior, timestamp, behavior. In your notebooks, providing illustrations is a very important feature. The illustration does not have to be high art. What it needs to be is clear. Stick figures are great illustrations of behavior, so long as you can show movement, so long as you can show the different morphology of the animal as it transitions from one state to another. And then in that, you want to have a description. Illustration of aggressive wasp, note raised head relative to body. Make sense? When you use time, always use military time. Do not use AM, PM. So 0800 hours for 8 a.m., 2000 hours for 8 p.m. Alex Marsh, what do we always use military time?
Because whenever you're running statistics, it gets confusing whenever it's talking about 8 and 8 p.m. So it's easier to run statistics and analyze things whenever you have a straight numbers through instead of repeating numbers for the same thing.
Alex, that's a great observation. So if you want to do data analysis, you need to have a unique number associated with each time. If you have two 8s, it's hard for most packages to sort of differentiate what an 8 a.m. is versus an 8 p.m. Connor, Cheryl, what's the other major reason?
Not entirely sure, but I believe it'd be just to keep good consistency. Like it's a good force of habit just to have a 24-hour span of time instead of repeating AM, PM all the time. Could get a little confusing.
Oh, no. Yeah. Can anyone think of it? And I'll give you a hint that's not a very good hint. It has to do with your arch nemesis. And you all have an arch nemesis. A truly evil person who is trying to undermine your every success.
It's yourself.
Your past self. If you put down 5 as an example, what time? 5. Because that's when you saw something. In 2 weeks' time, it will be very confusing whether you meant 5 a.m. when you started your observation of a crepuscular animal, an animal that's active during both dawn and dusk, or 5 p.m. Without taking good notes, it becomes very misleading for you to differentiate what you were talking about just a few days later. We'll talk about this both in terms of note-taking, and we'll also talk about this in terms of file management during the course of the semester. But you want to get a very good habit of providing yourself complete information so that you understand what you were trying to describe, state, communicate at any point in time in the future. Make sense? And we'll talk about your arch nemesis again later in the semester. So every lab note should have a time entry, and that would also include each time you're switching from one page to another. If you use shorthand, make sure that you have a legend that defines that shorthand. This is something that actually comes up quite a bit when we use something like Excel in a spreadsheet where we may not want to write out a whole variable name. Instead, we use a little shorthand to describe it. You always want to have a legend, a key, an index that defines what that information is. Okay, if we can, let's go and take another 5-minute break and we'll actually get into a little animal behavior. Come on back at 12:45. Okay, I'm gonna try. Can you see this as a full screen? All right. Oops. So, yeah, to Charles' question, and can see the chat. Don't hesitate to voice it out. I make the PowerPoints available on Canvas, though I do remove two things. I remove the videos and I remove the questions that I have pre-planned to ask in class. And you'll be able to identify the pre-planned questions because they're in red. If you want to take a screenshot of it, go ahead. Or if you want to take a photograph of it, don't hesitate. The reason I don't give you the pre-planned questions is I want you to think about them with reference to what we've been talking about and not think about them beforehand. So it's just a little device there. The reason I don't give you the videos is two parts. One, the videos tend to be very large in file size. And two, a few of them are, the copyright is unclear. So I don't do that. Where the video can be linked, I will give you the link. Unfortunately, one of the best inventions of the internet, something called archive, went down about a year and a half ago. Archive was an effort to document every vertebrate animal on the planet with both images and videos of the behavior, largely using the archives from the BBC documentary series. All of them were unnarrated. They were awesome and they were freely available. Really, really great resource, much like Wikipedia, but much like Wikipedia, they were funded through private donations, and much like Wikipedia, very few people donated. Archive eventually ran out of money. You know, whether Wiki does or not, I don't know. We'll find out. Questions with that? Okay, this is going to be on the final, this illustration. This semester, we'll give you all the information you need to know to understand the illustration, but that will be on the final. So I'm gonna have to make this a little bit smaller and split this up. Okay, I can see stuff now. That'll work. We talked about this, but I do want to sort of make clear. This is an introduction to behavioral biology, and behavior will be focusing on the mechanisms. Behavioral ecology, should you choose to take that, will be focusing more on the adaptations. I haven't talked to Dr. Croshaw in a while to see sort of how much he has differentiated, but that's the basic goal behind those two. So what I'm going to do is I'm going to show you a video. I'm going to show you a video a second time, and then I'm going to send you guys out into breakout rooms. What I want you to do in those breakout rooms is I want you to answer a very straightforward question. What is behavior? To inspire your thinking, I want to give you this Chamber Nautilus. This is an example of the old archive page. I'm going to show you again 2, maybe 3 times before sending you guys out into those breakout rooms. As a group, I need you guys to come up with a definition for a behavior. Never done research on cephalopods, but I love cephalopods. And as you'll notice throughout the course of the semester, we're going to focus on a few animals as models for our understanding behavior, and cephalopods will be one of those. Okay. This is a deceptively simple question. Pay attention to the word deceptively. What is behavior? In order to study the science of animal behavior, you must know what a behavior is. Sound good? Gonna send you guys out into breakout rooms to come up with decisions, and let's make rooms of 3 to 4 people. Room should open up, and I'll call you back in about maybe, I don't know, 5, 8 minutes, somewhere in that ballpark. Set a timer for 4 minutes.
Okay, 4 minutes and counting.
Set a reminder to email June Stein about the John Herman Foundation for next week.
Done.
Just while I'm thinking about it, because I was doing this while you guys were in that conversation, we'll be putting on a number of different talks and opportunities throughout the course of the semester. I don't know if I added research day, but research day is going to be April 16th, if you haven't heard already. And for the first time, we're going to be doing this in collaboration with all forms of student excellence. So we have a new setup called EagleX, and it will be Research Day at EagleX, Community Engagement Day at EagleX, Leadership Summit at EagleX, and oh heck, what is our fourth one? Internships at EagleX. So students in all these different fields have the opportunity to sort of share their experience, share results, and stuff like that. What I actually want to tell you about is on Wednesday, January 27th at 3:30, the first Whitaker Center seminar is going to be with a gentleman by the name of Terrell Morton. And he's a researcher at University of Missouri that works on strategies to engage more diverse students in STEM, particularly focused on biological sciences. So last semester, I heard him give a talk on the hemogenic whiteness of biological sciences. And if you guys don't know us, a lot of the history in biology has been pretty profoundly racist. One of the individuals that I had admired greatly, a gentleman by the name of R.A. Fisher, who is sort of the beginning of statistical sciences, and maybe beginnings and overstatement, but he developed the concept of a p-value. He developed the ANOVA test in collaboration. He developed with the t-test. You know, the stats that you use in your basic statements. He did this largely as a tool for a variety of things, but also to reinforce eugenic ideas and to sort of limit access, particularly for him, Africans, from being involved in greater society. That's a problem. For people who took biostats in previous years, I used to celebrate Fisher. If the student knew more about Fisher than I did at that time, that's a fantastic barrier. So this gentleman does research in terms of how to ensure we make sure everyone has the opportunity to be involved in biological sciences. And as we'll see, probably not today, but at the end of Tuesday's class, diversity in science is key because of the questions that you ask, the answers that you get, and the insights that we have in terms of having a full understanding of the studies that you're most excited by. So keep that penciled into your things. That is June 27th, 3:30. The guy's awesome. The talk I heard was fantastic. And I'm very much looking forward to inviting him here. Cool? Awesome. So thank you for the indulgence of 4 minutes because I got to do that while you guys got to talk. So I asked you a question. I'm going to put your answers in the chat. So what is behavior? Megan, what did the group come up with?
We basically all agreed on the way an organism responds or reacts to something in its environment.
Organism responds and reacts to something in its environment. Is that correct? Is that what I heard?
Yeah.
Yeah, so for all of you guys, I'll keep your chat open as you're seeing stuff as well. Oh, that's interesting. Shakora, I don't think I saw Shakora earlier here yet. New. Millie, give me an example using that definition that would be behavior.
Say something reacts to something in its environment. I guess with the cephalopod video we watched, I guess an example with that would be an interaction that it would have with something else that's in its environment. So maybe another animal in the environment, interactions that it would have with that maybe.
So it
And
could be,
that's behavior in response to another animal.
I like that. So it could be a biotic interaction. And I didn't see that in the cephalopod example. Did you?
No, I just meant like on the topic of cephalopod.
Nope, it's a great example. Great example. Could it be a abiotic interaction? So I'm going to mispronounce Cindy. Cindy?
Yeah. You're asking if the cephalopod was having an abiotic
Could it interact with an abiotic
interaction?
part of the environment?
Yeah, I think so. I'm trying to think of a specific example.
What about the video? Did you see an example from the video?
I mean, to me, the only behavior that I really saw and understood was that it was swimming, I guess. There wasn't a lot of background to it to see if it was swimming away from something or if it was just.
So that's a good observation. It kind of reinforces Millie's point. So, and it could have been swimming away from the person taking the video, you know, as a person taking the video approaches, swimming away from that. But did we see anything that was an abiotic interaction? And there has to be a little bit of an induction for this. It's not that you may have physically measure it to know, but I think we could probably reason out. And JC, you're up next. Oh, I don't see JC right now. Do I? Nope. Dakota.
You're asking if there was an abiotic interaction?
In that video, did we see an abiotic interaction?
Well, I don't know for sure if this is what the chambered nautilus was doing, but it looked to me like it was just propelling itself forward maybe via water movement. So I guess the way the water reacts to those motions,
okay,
like the physics of it.
Yeah,
But
the movement of the water through the body creating propulsion. Is there another reason we may have seen the sort of the radula of the chambered nautilus open and close?
Is it feeding?
Could be feeding. More likely that it's actually circulating water across its gills.
Oh,
so
for
respiration.
gas exchange.
Yeah, I like those.
Okay.
I like those. Shyler.
Yes.
I think Megan started us off on a perfect example. I think Millie, Cindy, and Dakota gave us good sort of examples to illustrate that point. But I think you would agree with me that while this includes a behavior, this is not a definition of behavior, right?
No, it's more just like doing basic muscle movements. I would say like how we just walk and how we just breathe. It's not like a response to something. He's more
that
just
could be-
doing.
Well, I mean, when we're walking, what are we doing?
I mean, we are making like the conscious decision to walk.
Does it have to be conscious?
No.
No.
But
No. Any sleepwalkers among us? I have a long family tradition of sleepwalking. I am more of a sleep talker. You know, I like to sort of have long conversations. And then have you guys walked around relatively unconscious to what you're doing and just find yourself in a random place? You're like, that's weird. Yeah. So, but I'm going to go back to my question. I think Megan got us off on a really, really good start. But Liz, I think you would agree with me that that is not a definition of behavior. It can be behavior, but can also be a lot of other stuff. Right, Liz? Where am I seeing Liz? Oh, no, Elizabeth, I remember. I got enough from Elizabeth. Marissa.
Yeah. So what was your question?
Well, you agree with me, right? That that's not a definition of behavior.
Yeah, not specifically, but
Not
in general,
specifically.
yeah.
It includes behavior, but not specifically behavior. Marissa, can you give me an example of another thing an organism can do to respond to its environment?
Well, could say like kind of like what I was talking about at the beginning of class with introductions, how there was like bears in my neighborhood. One of the reasons they could have been behaving the way they were coming to doorways could be from like smells of food. And that could be like cause them to behave like that.
But that's fitting into Megan's definition. Yeah, that works for Megan's definition. But this is kind of a square and a rectangle thing. A square is a rectangle, but not all rectangles are squares. This definition does include behavior, but it also includes development, immunology, physiology, morphology, genetics. In fact, that definition includes every biological trait. So I would like Heather Peterson, I would like you to give me, and I'm looking for Heather, where's Heather on my screen? Oh, I see Heather. I would like you to give me an example of that definition that's non-behavioral. It doesn't have to be a chamber analysis. In fact, it could be you, it could be me, it could be anything. That's
Non-behavioral?
not a behavioral response to something in the environment. It might be physiological, might be developmental, might be genetic.
Sometimes some aquatic, I don't know about this one in particular, but sometimes they can change the colors on their bodies to respond to like better blend into their environment for hiding from predators and stuff. And I think that's like a genetic type of.
There's a genetic component of that. There's a morphological component of that. And there's a behavioral component of that. All those are swept into the same thing. Ooh, I like that. I like that. But that still has the behavioral component in it. Oh, yeah. Ella, you're up.
You want the same thing?
Yeah. I want something that's clearly not behavioral. Definitely not behavioral, but it is a response to the environment. Because Megan's statement was really good. It gives us a definition of a trait, a phenotype. So I want us to understand.
If it's hot, you sweat. That's like physiological. If it's hot, you sweat out, you know?
If you're hot, you sweat. I love it. I love it. I was thinking of the sort of, I remember my courtship days, and I'd go up to someone who is attractive and my heart would be beating a mile a minute. I hadn't said anything. I hadn't, engaged in the interaction, but the physiology was very much there. The palms were sweaty, so there was no handshaking going on. The heart is pumping, trying to keep the blood out of the face as I approached the individual. All of that physiological. Was I responding to the environment? Oh, yeah. Oh, yeah. Yeah. Ella's example. Perfect example. The idea that.
Oh, can I say something?
Yeah, give me 1 second, Jay. The idea that you go into an environment and you're hot, you start to sweat. Great example. Jay.
Since we're talking, now that you mentioned like your heart pounding and like when you see other people, whatever, could we talk like with mating, like the different mating mechanisms will fall into the as well?
Okay. So you're making a very good observation that the physiology could be linked to the behavior. True. But we can also look at the physiology independent of the behavior, which is still a response to the environment. What about this situation? We just had a political cycle, and I love every time we have a political cycle, there's cool papers that come out in Science and Nature about weird things associated with politics. And not this presidential cycle, but the previous one, 2016, there was a paper that came out about the gene DRD4. Does anyone know the gene DRD4? It's kind of a famous gene. We talk about it quite a lot. Maybe you guys heard about it in a different class. Do I got a DRD4 aficionado? DRD4 is sometimes called a novelty-seeking gene, which is a terrible phrase, but it's a gene that is expressed with novelty-seeking, And in rat studies, the expression of that gene is associated with rats that explore novel environments. And the downregulation of that gene is associated with rats that stay relatively sedentary and don't go into new and novel environments. Kind of make sense? Novelty seeking. In humans, there was a cool study that came out which showed that if you had a particular allele, I want to say it was delta 32, but I'm not 100% sure, so don't take that down as a note. But you had the gene, you had a particular allele of that gene, and you lived in urbanized environments, then you were likely to express it and demonstrate progressive political views. Love that. That is a reaction to the environment in how the genes are being expressed. And it fits Megan's definition perfectly. Would we agree? Is it a behavior, the expression of the gene by itself? Not by itself. It becomes a behavior when we talk about the expression of the trait, in this case, the progressive point of view. Then it becomes something. So anything in biology that responds to an environment, that's a trait. That's a trait. And we see that in development. Right now, I am showing a form of development, and I'm growing every day. I get a little bit wider as I become increasingly sedentary. Is that behavior? No, it's really kind of morphological. And what's leading to that sort of enlargement? Now, of course, I look really enlarged because I'm in New York and I'm freezing. So I think I have, well, I have reindeer thermals and a t-shirt and a vest jacket and another jacket. I got 4 layers going on sitting inside the house. It's cold. But what's leading to that sort of horizontal expansion?
Behavior.
Well, behavior, but what aspect of the environment is leading to that horizontal expansion?
The weather.
Could be the weather, cold.
Your activity,
What's that?
like your activity as a response to the weather.
My activity, maybe it's sponsored weather, maybe COVID-19, not moving around as much. Third factor we could think of?
Your choice, your personal choice.
Could be personal choice. Absolutely. What's my stage of development relative to you guys? Am I old or am I younger than you? Or are we the same?
You're old.
I'm old. And what happens to metabolism as organisms get older? Especially endotherms.
It slows down.
Slows down.
Down. So you guys could have the exact same caloric intake as I have, and I'm not going to need as much of it because it slows down. There could be an increase in caloric intake. All of those are environmental characteristics. Some of them are external, some of them are internal. All of them influence the trait that we're talking about. In this case, we're talking about morphology, right? And we talked about cases where the behavior is influencing the morphology, sure. We talked about cases where the physiology is influencing the morphology, great. We talked about things that are unique to sort of just the individual me. And then we talked about those things that are outside me. I am not the pandemic. No matter how much someone might think I'm a scourge on them, I am not the pandemic. But all of those fit the definition that Megan had. Megan, that's a great definition. But that definition defines a biological trait. It does not define a behavior. I will see you guys in 5 minutes. I'm going to keep you in the same breakout rooms. And this time, I would like a definition of behavior.